So we've reached the point where we've looked at all the calculations and the different ways that you can divide fractions, whether it's a whole number divided by a fraction or a mixed number or improper fraction. Any of those combinations we've looked at. And so now we get into the nuts and bolts of it. The when do I actually need to do this? And so the challenge with word problems is that sometimes it doesn't go right out and say, you need to divide 3 divided by 1/8. You need to interpret the problem and figure out what you need to do. Because even if, let's say you have a word problem and you think it's multiplying fractions, even if you accurately multiply those fractions, the answer that you get is still going to be wrong if it's actually a dividing or a division problem. So we need to look at some characteristics of division real-world problems to help us identify, is this scenario division, is it multiplication, is it addition, or maybe is it subtraction? So with division problems, you are always going to know the total. And the total is going to be the amount that you have. It's what you're starting with, or it's what you're breaking up. It's not you, it's me. We just need to break this one up. So with this breaking up, I'm going to scoot this over to the middle because you have kind of two directions that this could go. In some scenarios, you might know the total number of groups. So you might know the number of groups. So that might be a problem that sounds something like Mr. P has 3 pans of brownies. He needs to make 5 equal-sized groups. So the total that we have is the 3 pans of brownies, and then the groups are the 5 groups or portions. And so this problem, when you know the number of groups, you're going to be asking about how, that's not an H, how much is in each, or how big is each portion. On the flip side of this, when you know the total and you know what you're starting with, you could be breaking it up where instead you know the size of the groups. And so in this similar problem with Mr. Plaska, he has 3 pans of brownies and is making portions that are 3/8 of a pan. Then the question is, how many portions can he make? Oops. So we know our total has 3 pans, and this time I'm going to make this look the same as that one. The question is asking this. So we are going to be looking at each size, each portion is 3/8. So that's where it is. How big is each portion? And we want to know how many of those portions. So just a quick recap. With division problems, you're always going to know the total, and then you're either going to know the number of groups and be looking for the number in each, or you are going to know how big each group is, and you want to know how many groups are there. So you have to do a little bit of work to see what it is, and then visually, when you're mapping this out, your total is going to be this amount that you have up here. This is your total, and there's at least two different ways that you could show this. Your total, and you're either breaking it up. Here we know that this is our 3 pans, and we knew that there were going to be 5 equal groups. And so we want to know how big is each group. So if I were to color code these, here's our number of groups. Here is our total. And then the amount in each is going to be in there. Now, this, for the other one, when you know the size of the groups, you still have your total, your 3 pans. But this time you know that there are 3/8 in that one. You don't know how many there are, but you know that each one of those is going to be 3/8. You just don't know how many of those groups can you make. So we do know this piece, the number in each. We still know that total, but we are just then looking for how many of those groups would you break it apart. So mathematically, in these two scenarios, because we know it's division, because you are starting with your 3, you're dividing it into 5 equal-sized groups, and that's going to get you your answer. When we know the size of the groups, we have our 3 pans. We're dividing them into 3/8 of a pan, and we want to know how many of those can we make. So again, if we were to color code one more time, we know our totals. We start with 3. On the left side, we know the number of groups. We have 5 groups, and we're looking for how big is each. On the right side, we have our 3 groups. We know that each group is going to be 3/8 big, and we want to know how many groups. So this is our total. This is the number of groups. And this is the size of each. On the right side, again, we have our total that we have. This is the size of the groups. And we're looking for the number of groups. So that kind of is like the way that you would figure out, is this going to be a word or a division problem? And then what are we going to be dividing? Because even when we zoom in on these problems here, we have learned how to do 3/8 divided by 3. And so taking a moment to draw this picture really shows, like, are we breaking apart these 3/8 into 3 groups, or are we breaking this 3 wholes into groups that are 3/8 big? And so taking a moment to draw a quick sketch is going to help you make sure that you are doing the correct division. So you might be able to actually compute that, but if it's not the right computation, who cares? So let's use this kind of flow chart to see if we can solve this one. So Nicholas had 3 kilograms of flour. He uses 3/4 of a kilogram of the flour to make apple cider cookies every day. How many days did he take to finish all the flour? So I'm just going to list off on this side. Well, first off, when dealing with these problems, I like to identify what the answer is. So putting it into a sentence. So it took Nicholas blank days to finish the flour. So now I know, as I'm working through this, I'm always thinking that this number is the number of days. And so I have to be thinking about how that answer might be important. Now, I'm just going to list off the information that we know. So Nicholas has, or you have 3 kilograms flour. And it looks like for each batch, he's going to use 3/4 of a kilogram. So that, to me, in my head, I'm going to do these at the same time. Like, I have this total amount of flour. It's 3 kilograms. And if I make one batch of cookies, it uses 3/4 of a kilogram. And so then I would be able to make another batch, which is another 3/4 of a kilogram, and I could make another batch, but I don't know how many of those batches I'm going to make. So based on that quick little sketch, the amount that I have, this is my total flour, is that I know my each, because each batch uses 3/4 of a kilogram, but I don't know how many batches. And in this, that's going to be our groups. So we don't know that. So the math that we're actually solving is I'm taking the 3 kilograms that I have and I'm dividing it into groups of 3/4. And I want to know, how many is that going to be? Well, we know that we can multiply by the reciprocal. So 3 times, when I flip 3/4, I get 4/3. I'm going to simplify because that's the same there. So 1 and 1. I'm going to rewrite for accuracy's sake. And now I can multiply. So my answer is 4. And if I go back to my original equation that I'm solving here, I have my bigger number divided by my smaller number, so my answer is going to be a whole or a mixed number. So this does seem reasonable, that it could take me 4 days, or it could take Nicholas, this mystery Nicholas, 4 days to use up all that flour. Seems pretty good.